Hi everyone, welcome to this video. Here we will discuss everything about motion and how to describe a motion. Let's discuss all basic aspects of what do you mean by position, distance, displacement, velocity, speed, acceleration, all of them, not just in the form of formulas, but we'll understand the real beauty behind all these concepts. Okay, so the power of conceptual understanding you will get to know in this video. Okay, so be ready, be committed, take lots of notes. Okay, first and foremost, if somebody asks you what is motion, what would be your answer? So maybe for a common man who does not know anything about science, if you ask him motion or if you have to explain the motion for him, first word that you would use is motion is nothing but movement. Okay, and where do you find movement? Everywhere there is movement. The blood inside you is flowing continuously, the birds are flying, the branches of the trees always move, and look at here, the swimming that you go from one end to another end is a motion, right? So that is a movement, and this car is moving, the train is moving, even the ball that you just put it in the basketball court, you know, that itself is called as a movement. So the earth is moving, it's moving around the sun, it is moving around itself, the entire solar system is moving. In fact, the entire universe is in movement itself. Okay, but this word movement is a normal word. Okay, but in science the movement is called as a motion. Okay, but of course you have a different definition and different meaning in physics. So let us understand that meaning of the word motion. Okay, so before even we understand the definition of motion, you know, you need to know two things here. Okay, so one is the position, what exactly we mean by position, and what exactly we mean by time. Okay, because the motion, the definition of motion, the meaning of the word motion is associated with these two words. So first let us understand what exactly we mean by position. How do we describe position? Right, so this is very important. How do we describe position here, right? And the other one is time. We all know time always changes. Okay, so time is not constant, time always changes here. Every second, every microsecond, it keeps on changes. Okay, you cannot hold the time, right? You cannot keep the time constant. So it is the quantity that always changes in the universe, right? Okay, so let's understand about position. So before I talk about position, let me ask you one thing. Say your friend is coming to your place to spend holidays. Okay, so he is traveling by bus. He traveled and he came to your place and you called him, okay, to have an inquiry about where exactly he is. So you called him and you asked, where are you? And the guy, your friend on the other side said, I am here, I am there, I am here. What does it mean? If he tells I am here or I am there, what does it make? Does it make any sense? No, right? But instead of that, your friend says that he is 40 meters right side of the bus stand. Okay, now the information is very clear. Okay, so this is your friend and he is exactly 40 meters away from bus stop. So this is what we mean by describing position here. Okay, so let me change the color. Right, so here the bus stop will act as a reference. So whenever you talk about position, we always talk with respect to reference. Yes or no? Say suppose I am near temple, right? So I am near school gate. So my home is near this place or this bank. My place is near to this temple, right? So always whenever you describe position, there comes becomes a reference point. You'll always keep something as a landmark and you'll always keep something as a reference. So here your friend told, I am 40 meters right side of bus stop or bus stand. So here the bus stand is acting as a reference. And your friend also told, I am 40 meters away. That means what is this 40 meters? So this is talking about the distance. Okay, and not only that, I am right side of the bus stand. Yes or no? This is a complete information. Right side, I mean, what is this? Right, left, or something like that? They are direction. Okay, so you have to combine some reference point, you have to mention the distance from the reference point, and also you should include the direction, right? So all of this combined together can describe the position, right? So what is a position here, right? So if I have to define a position or if I have to describe a position, so it is nothing but the distance. Okay, it is nothing but the distance from where? Distance from reference point. Distance from reference point in a particular direction. In a particular direction. Okay, so this is how we can able to describe the position, guys. So now in physics, this reference point can also be called with the word origin. Okay, so in physics, in many of the problems, when you want to describe a position, no, so we just take axis. Okay, so the horizontal line we take, and some point on a horizontal line we keep it as a reference. Say here I am taking a x-axis, so exactly the 0 on x-axis I will consider as origin. So this is my reference point. So now this is a distance, right? So this is 1 meter, this is 2 meter, this is 3 meter, this is 4 meter. Okay, so the right side values all are positive values, right? And now if you go on the other side, I mean the left side values are negative values. This is -1 meter, this is -2 meter, and this is -3 meter, like that. Okay, so the distance we always consider in the form of x-axis, one big number line. So I can say that it's a number line where exactly some point, okay, origin always it should be 0? No, need not be 0. I can consider 2 meters as my reference point, or I can consider -2 meters as my reference point. So your reference point can be anything, but usually we consider that 0 point on a number line, no, that as a reference point or origin. Okay, so now if a boy is standing here, say a boy is standing here, then how do you describe the position of this boy? Or if any object is there, how do you describe the position of that object? You will describe the position of object as 2 meters from, okay, so he is 2 meters from origin. Okay, what is the origin? 0 is the origin, and 2 meters, and he is 2 meters right from origin. Say the direction is also very important. 2 meters right side. I can simply say that the position of this object is just +2 meter. If the object was here, okay, suppose if the boy is standing here, then what is the position I say? The position of this boy is -3 meters from origin. Okay, right? What does this minus indicate? This minus or plus? Okay, this minus or plus indicates the direction, guys. Okay, so the position can have a positive value and it can also have a negative value. Remember this. But here the minus, the distance cannot be negative, right? But still we say the position of this object or a boy is at -3 meters. Here minus means direction. Okay, so if it is a backward direction, you indicate with a minus sign. If it is a forward direction, you indicate indicate with a plus sign. Okay, so here when you see a negative value for a position, okay, remember that negative sign they have indicated because that particular object is in backward direction. Maybe it is going to left side of your x-axis or a straight line. Okay, right? So this is all about the position, guys. And remember, many a times during calculations and etc., position can be represented with the symbol x. Okay, so whenever you have a symbol x, it means that position. Say suppose in some kind of questions they would give you x is equal to 1 meter, x is equal to 2 meter, x is equal to minus 4 meter. So this is how they might give the values. Okay, so what do you mean by this x? X means position. Position is indicated with the letter x. It can be capital X or it can be small x. Okay, so hope you understood about position now. Okay, now coming to the word motion, guys. Okay, so this is all about position, right? And now look at this picture. Okay, say suppose at time t is equal to 0 seconds. Okay, so when time is equal to 0, the position x is equal to 0 meters. I mean the position of this boy was at 0 meters from the bus stop. Okay, right? But now as time changes, so after 2 seconds, okay, after 2 seconds, the position of a boy was at 10 meters from bus stop. Okay, and after 2 more seconds, okay, after 2 more seconds, the position of the boy was at 25 meters from bus stop. Okay, and after 2 more seconds, that means altogether after 6 seconds, the position of the boy was at 40 meters from bus stop. So what did you observe here? Okay, see here, as time changes, the position of a boy also changed, isn't it? Is the boy 24/7 will stand at 10 meters position only? No, right? He will move definitely. Okay, so when there is a movement in the position of a boy, as time changes, then that concept or that thing is said to be as motion. Okay, so what do you mean by motion here? Very simple here. So motion is nothing but, okay, motion is nothing but change of position. Okay, change of position of an object, okay, with time. Okay, with time. So what is motion here? Position changes as time changes. Time anyway changes. Time is not constant. You cannot hold the time as it is. Anyway time will pass. So as time passes, if you see, the object position is also changing. Position means going from one place to another place, isn't it? So position means what? Going from one place to another, from another to another. So position of an object is changing as according to the time. Then such a concept is called as, that is what we call it as a movement in physics or in science, and we are giving a fancy word for that, and that fancy word for that movement is nothing but motion, guys. Okay, but what is the opposite of motion here? Opposite of motion is rest. So what do you mean by rest here? Simple, guys. Position does not changes. Okay, position does not change. Okay, but what about time? Time always changes. Okay, you cannot restrict the time. Time changes, but position does not change. That is what we mean by rest. Okay, so you should clearly understand the meanings of rest and motion here. And one more important concept here, position can be represented with mathematical term. Okay, so what is position? I mean, what is motion? In fact, change in position. No, so there is a kind of representation for change in position. So what are we talking about now? Representation. Okay, so there is a representation for change in position, guys. Okay, see, let me talk about coming to this picture. Say I will consider these two positions. Okay, so the boy standing at 0 meter, okay, and the boy standing at 10 meter. Okay, so this is a position at this particular time, and this is a position at this particular time. So when time is equal to 2 seconds, the boy's position was at 10 meters from the bus stop. Okay, whenever you talk about a position, reference point is very important. 10 meters, if you just say, what does it mean? 10 meters from where? 10 meters from the bus stop. Okay, yes, fine. So this is a position at 2 seconds and this is a position at 0 seconds. Okay, so here this what I told you, position is represented with the letter X. Okay, so this is X and this is also X, but I consider this as the final point. Okay, so it is a final position and it is a initial position. Okay, so final position is X final, initial position is X initial. So motion is nothing but the difference between final position and initial position. Yes or no? How do you find out the change? How do you find out the change here? Say for example, right, so X final minus X initial. Okay, so you will get change. Okay, so you will get change in position. You will get change in position, isn't it? Change in position, guys. Okay, so now this X final minus X initial gives you the change, and to express the change we use the symbol delta. So whenever in science or in physics, whenever we use this symbol, this is called as delta. Whenever we use this symbol, it means that we are talking about a change. We are talking about the difference between the two quantities. Okay, two same quantities, isn't it? So the change in position. Okay, so change in position can be represented as X final minus X initial. X final means what? It is a final position of an object. Initial means this is the initial position of an object. Madam, why do you consider final position as this? Why don't you consider this as a final position? Yes, I can consider. Okay, so if I consider final position as this, what do I get? This is X final and this would be the X initial. So 40 minus 0, I get 40. So that change in position is 40 meters. Okay, so 40 meters per second. So that's how we say. Okay, right? So hope you understood about how to represent the change in position. So always whenever we write delta X, it represents the change in position. How do you find change in position? Final position minus final position at some time minus initial position point at some time. Okay, so that is what we call change in position. So this change in position with respect to time itself is called as a motion, isn't it? So that's what we have discussed. Okay, so now we need to understand one more important idea. What do you mean by time instant? What do you mean by time instant and time interval? Time instant and time interval, guys. So it's very, very important to understand the difference between time instant and time interval. Okay, time instant means exact time. Okay, exact time on a clock. Okay, and what do you mean by time interval? It is the difference between It is the difference between two time points. It is the difference between two time points. So what do you mean by this? So you might be confused when you look at these definitions, right? Let me show you in this example itself. Look at here. This boy's position was 0 meters exactly at time t is equal to 0 seconds. Or when time 2 is equal to 2 seconds, his position is exactly 10 meters. So exact time point, okay, so that you observe on a clock is called as time instant. At this time point, the object is there at this point, okay, so at this distance. So that exact time point on a clock is called as time instant. Whereas what do you mean by time interval? It is the difference between this time and this time, okay, so this gap, the time gap between the two position points, okay, so time gap. What is the time gap between these two position points? Here it was 4 seconds, here it was 2 seconds, so 4 minus 2 is equal to 2 seconds. So from this position point to this position point, what is the time difference you have? That is called as time interval, okay, right? So at a particular time, when you talk about that time is called as instant time or time instant. So when you are talking about a difference between a time, okay, so your interval means what? Gap, isn't it? So the time gap between the two reference points or the two position points is called as time instant, okay, right? So hope you understood about instant time and time interval, isn't it? So this meaning is very, very important, guys, okay? So we understood about representation of change in position, we understood about time instant and time interval. So now let us slowly move ahead to a concept of distance and displacement. These two ideas are very important to understand and they are very, very fundamental. Many students and as well as many teachers also get confused with minute aspects, but understanding them conceptually is very, very important. So let's decode everything about distance and displacement here. So guys, imagine a ball was initially here, okay, so it moved to this place, okay, so let me just show it in another page. So I have a ball here, so I threw a ball and it traveled and it came to this position, okay, so it was initially at position A and after throwing it traveled a certain path and it came here, okay, right? And now look at here, this is the path traveled by the ball, okay, so what is this? This is a path, so this is nothing but a path traveled by the object, okay, instead of ball I'll call it as object, path traveled by object, and it is a total path, okay, so this is a total path traveled by a object and this is what we call it as distance, guys, okay, so this is what we mean by distance, right? And now what do you mean by a displacement? Change in position. See, the word displacement itself has all the meaning, guys, okay? So what is this word? Place. Dis means changing, isn't it? So change of place. What do you mean by displacement? Change of place, okay, from one point to another. One point to another is called as displacement, okay? Say ball was here initially, from this point the place was changed to this point, and here is the direction important. So in which direction the place change took place is very important. See, the place of a ball changed from point A to point B. So this is point A and this is point B. So this ball changed its position from point A to point B. Okay, so the direction is mentioned with the help of arrow mark, isn't it? So displacement has got both magnitude. How much is the length of this arrow? So just understand, guys, displacement is all about arrows. Okay, so let me change the color. So displacement is nothing but an arrow. Okay, and look at here, this arrow has got a length. Okay, the arrow will always, when I draw a arrow, how would you draw the arrow always? From original point of object to final point of object. Okay, so this is the final position, isn't it? So this is x final and this is x initial, isn't it? So now this x final minus x initial will give you change in position. Actually, that change in position, that quantity itself is called as displacement. Okay, so this itself is called as displacement. Okay, so this is just an arrow. Arrow will have a length and arrow will have a direction also. Okay, so from original point to final point, you will draw an arrow and you will show that as a displacement. Okay, so arrow will always have a length. It will have some distance, right? From here to here, there is some distance covered. You know, that is what I am talking about, a length here. So maybe it is 20 meters is the distance covered. So that 20 meters is what the length. Okay, and in which direction it is going? It is going towards a right direction. Okay, so this displacement is a quantity. This displacement is a quantity which has got both magnitude, length. This 20 meters, so this numerical number is there, no? This 20 meters, this is what we call it as magnitude. Okay, so it has got a magnitude. Magnitude means how much. How much is the distance between the original point and the final point? It is the distance between the original point and final point, guys. So that number, you'll always have some number, no, 20 meter or 30 meter or whatever it is. So that is what we call it as magnitude. So it has got both magnitude and it has got direction. So in which direction the object as displaced, that also is very important. Okay, so usually the direction here can be positive or negative. Okay, so when you are talking about the motion in a straight line, so the entire chapter deals with motion of object in a straight line. So the object will move only on a straight line, right? So motions can be of different types. Say the object can move circular, the objects can rotate and move, or whatever it is. But the entire chapter is restricted to study the motion of object that is moving in a straight line. So when the objects are moving in a straight line, you know, it can have a positive value if it is moving on right side. Okay, like this in the forward direction. It can have negative values. Okay, it can have negative direction if the object is moving on the left side, guys. Okay, so here the direction of arrow can be positive if it is moving like this. The direction of arrow can be negative if it is moving on the left side. Okay, and in physics, any physical quantity which has got magnitude, okay, which has got some length and which has got some direction, I mean any physical quantity that is studied by putting this arrow marks are called as vectors. Okay, so what do you mean by vector? Vector is some name that we have given for arrow. Okay, so arrow will always have some length, some value, some distance covered, some length, that is called as magnitude, and arrow will always have some direction, either forward direction or backward direction. So arrow, instead of calling a word arrow, just in science we have introduced a fancy word that is called as vector. Okay, so displacement is a vector quantity. Displacement is a vector, we say, because it will have magnitude, it will have some value, that's nothing but distance. Okay, and it will also have some direction. Okay, so it is the displacement, it is the distance covered by an object when it is changing from one place to another place. Okay, it is not the path traveled. Path can be anything. See, path can be anything. Okay, so it can come like this, or the object might jump and come like this, or whatever it is. Path can be anything, guys, but the object has changed from point A to point B. So this change in place or position itself is the displacement. Okay, right? Fine. So now few differences that we need to understand between distance and displacement here. Okay, so distance is a total path traveled, and distance cannot be zero, guys. Distance cannot be zero, but displacement can be zero. So very important, displacement can be zero. Okay, so let us understand this with the help of one beautiful example here. Okay, so suppose, okay, so I have a number line here. Say this is my reference point, which is 0. So this is my reference or origin. The origin reference point can also be called as origin here. Okay, so now I have an object at origin. Okay, say this object is some person. Okay, so now this person has traveled 2 meters right side. Okay, so he has traveled 2 meters right side. Okay, so from here he has traveled 4 meters right side only. Now he turned back and he traveled to minus 4 meters towards left side. Okay, so and here he stopped. Okay, so he stopped here, right? He stopped here. So understand this example. So the person was at origin. He started his journey from origin. So from here 2 meters to the right side, again from there 4 meters to the right side, then he turned back and again in a straight line he traveled around minus 4 meters to the left side. At this point he has traveled. So literally from this point to all along this point he has traveled. So now if you ask me, what is the total distance traveled by the man? Total distance traveled by the man is, from 0 to 4 meters. Okay, so 0 to 2 meters is here till here, then 4 meters. From this point he turned back and he traveled all along till minus 4 meters. See here, this entire path is the distance. Okay, so from 0 to 4 again he came back. Okay, came back, came and he stopped at minus 4. So what is the total distance here? 2, 4, again the entire distance he came back. So 4, okay, 0 to 4 is 4, again he came back, no? So plus 4 meters. Okay, and then this side also 4 meters he traveled, right? So plus 4 meters. So total 4 plus 4, 8, 8 plus 4, 12. So the total distance traveled by this person from origin, he went like this, he came back and he stopped here. Okay, so he went from here to here 4, again he came back from 4 to 0, 4 plus 4, and again from 0 to minus 4, this much distance also he traveled, so one more 4. So I have not included a sign. So the distance doesn't care about a sign, it's a total distance. Distance will not have a positive value or negative value, it's always positive in that case, isn't it? So this is how you can identify the total distance. But what is the total displacement here? So what is the displacement? So displacement is very important. So what is the initial position? Initial position was this. So x initial is equal to 0, guys. So what is the final position? Final position is this, that is x final is equal to minus 4 meters. Okay, minus 4 meters. X initial is 0 meters, x final is minus 4 meters. So what is displacement? Always do like this, x final minus x initial. This way if you do, you will not get confused. Okay, so x final is what? Minus 4 minus of 0, isn't it? So what is the displacement? Minus 4 meters is displacement. See, displacement can be positive, displacement can be negative, displacement can be 0. This is very important. Okay, see, what does this negative sign indicate? Negative sign indicate the person was traveling towards left side, that is in the backward direction. Okay, so now when does the displacement can be 0? Imagine the person, okay, suppose if the person, right, same example I'll take. So this person started from origin and he came back. Okay, so he traveled all along the way and he came back at the origin and standing here. So in this case, what is the total distance, guys? So in this case, what is the total distance? He traveled 0 to 4 and again he came back from 4 to 0. So that means 4 meters plus 4 meters. So total 8 meters is the total distance traveled by this man. Okay, and what is the displacement? So now what is the initial position? Initial position, x initial is equal to 0 and x final is also equal to 0, isn't it? So initial position was this. He went here and all along the way he came back and standing at the same position. So what is the change in the position? Nothing. X initial is 0, x final point is also 0. So 0 minus 0, so the displacement is 0 meters. Okay, so displacement can be positive, it can be negative and it can be 0. Okay, but the distance is always a positive number. It is the total path covered by an object. Okay, so hope you understood about displacement and distance. See guys, let's solve this question now. So here, they have given a table. Say there is a ball. Okay, so 0 was the starting point of a ball. Okay, so the ball started from 0, guys. So from here the ball was thrown up. Okay, it reached B and then from there it's coming down actually. Okay, so it's all happening in a straight line. Just to give you this differentiation, there are 2 lines here, but the ball went up, in the same line it is coming back. Okay, so they gave you different positions for a ball here. Say position, position 0 is the initial position here. Say there is a position A and there is a position B. Okay, there is a position C and again the position 0 back. Okay, so now the total distance traveled by the ball from 0 till that position. Okay, say for example 0 to 0, what is the total distance traveled? It's always a 0, right? So now from 0 to A, what is the total distance traveled? So here these values are distance values, guys. So these are the distance values. From 0 to A, what was the total distance traveled by the ball? It was 40 centimeter, like that. So ball is there from 0 to B now. So what is the total distance traveled? 0 to B. What is the total distance traveled? 140. Isn't it? Now 0 to C. So the ball went up, up, up. Now from there it is coming back to C. So what is the total distance traveled? From here to B is 140, we know. Now again from here to here it is traveling. So how much is this distance that it has traveled, right? So 20 plus 20, 40, right? 40 plus 20, 60. So 140 plus 60. So almost 200 centimeter the ball has traveled from 0 to point C. Point C is where? the ball went up B, from B it is coming wapas back to C. Okay, so this entire distance 0 to 140, then 140 plus this distance, so this distance is a 60, right? So 140 plus 60, 200. Now from 0 to 0, how much? So the ball was here, it went, and now it is traveling back to 0. So what is the total distance traveled by the ball? 140 to go up, again from 140 to 0 to come back. So 140 plus 140 is the total distance traveled by a ball from 0 to 0. Isn't it? Okay. Now let us check the displacement. Similarly, let us check with the displacement, guys. So let me just erase this. See, when the ball is at 0 position, when there is no movement, displacement is also 0 centimeter, right? So now the ball has moved to A. From 0 to, the ball has moved to A. So the initial position is 0. So the initial, okay, so the initial position is 0, final position is 40. But what we will do? Final minus initial, no? So final position is 40, initial position is 0, so you will get 40 centimeters. So that's what is the answer they have mentioned. So now the ball is moving at B. So the ball was here and the ball has moved at B. So what is the displacement, guys? What is the final position? Final position of a ball is now at B position. Initial position is at 0, isn't it? So final minus initial. So x final minus x initial, isn't it? So what is the final position? 140. What is the initial position? 0. So the total displacement is 140 centimeter. Okay. So now the ball is at C. Okay, so the initial distance was at 0, the final distance is at C, guys. Okay, C means what is the distance? 80. So the final distance is 80, the initial distance is 0. That means 80 centimeter. See, if you take up a total distance, it's 200 centimeter, but the displacement is just 80. So we only care about where is the ball. Here, C. C's distance is what? C's position is what? 80. So we only care about the final position and initial position. We don't care about the path. Okay? Yes. So now the ball is at 0 only. So ball went up and it came back. So this is the final position. This is the initial position. Both are 0. So here the displacement can be 0, guys. Okay. So now see here, from this one thing you can be very sure that displacement can be 0. Okay, so they are asking which of the following is true for displacement. They said it is never 0. This is false. This displacement can be 0. This is very important, but distance cannot be 0. Understand that. Okay, and then displacement's magnitude can be greater than the total distance traveled. Wrong. Okay, so the displacement value is always lesser. I mean the magnitude I'm talking about. I mean magnitude. Magnitude means without any direction. Only the value, the numerical value if you see for displacement. This is always, it is lesser than the distance traveled. Okay, displacement value is always lesser. Forget about direction, it can be positive or negative. So the magnitude means here only the numerical value that is there for displacement. So that value can always be equal or lesser than the distance value. Okay, so this is a wrong statement. Next statement, the magnitude, it means displacement here. The displacement's magnitude is less than or equal to the total distance traveled. This is correct, guys. Okay, the magnitude is less than the total distance traveled in all cases, not in all cases. Okay, it can be equal or it can be lesser than the total distance. Okay, so these are some differences that you need to understand between distance and displacement, which is very important. Okay, so next we will go ahead with speed, velocity and acceleration in a beautiful way. See guys, here few more questions that you can solve on displacement and distance. Very interesting questions. Okay, in the example of an athlete running back and forth on a straight track in figure 4.4, when will the displacement of the athlete be 0? What will be the total distance traveled in that case? Okay, so let's go back to that picture of an athlete. Say what they asked you. See, this is the picture of the athlete, right? An athlete running on a straight track. So she was here initially, so she ran maybe up to here and she came back wapas, okay, back. So what would be the displacement? So displacement is definitely it is going to be 0, because right, so this is a starting point and this is the ending point, so there is no difference between starting point and ending point, so definitely displacement is going to be 0. But what would be the distance? Okay, say for example an athlete is here, okay, she traveled all along like 100 meters, okay, and she came back to the same point. So this is 100 meters, right, and again from A to 0 she is coming back, and that is 100 meters, right? So 100 plus 100, it is going to be 200 meters, right? If you are taking this O as an initial point, she traveled up to 100, again from 100 coming back, if you consider, then 100 plus 100, the distance traveled is 200 meters, whereas the displacement is perfectly going to be 0, isn't it? So let's understand few other questions there, because the more questions you solve on this, the more perfect you become, guys. So that is the reason why I am solving the questions even in the video. Okay, so don't neglect solving questions, because the physics becomes friendly only when you solve varieties of questions. You should undergo through confusion and you should able to clear all your confusions. Only then you become perfect. Okay, yes. Then look at the second question. Fuel used up in a vehicle depends on which of the following? Justify your answer. Total distance traveled or displacement? So the usage of fuel always depends on the distance traveled. More distance it travels, more is the fuel that gets used up, isn't it? It doesn't depend on displacement. Okay, say for example, there is a car. Okay, so it has traveled from A to B, and again from B it has come back to A. So the displacement is 0 here. Does it mean it has not consumed any fuel? No, right? It has traveled from here to here and again from there it came back. So it has traveled a whole lot of a distance. So definitely there would be a consumption of fuel to a greater extent. So the consumption of fuel always depends on the total distance traveled, but not on a displacement. Okay? Yes. And third question, which is also interesting, say this is an inclined path. Okay, so a ball rolls down an inclined track as shown in figure 4.6. Is its motion a straight line motion? Yes, even if the path is inclined, it is considered as a straight line motion only, guys. So usually the motion in straight line is called as a rectilinear motion. So definitely it's a linear motion, considered as linear motion only, even if it looks slightly downward or inclined or whatever. The path is straight, no, so it's not like this, right? The path is completely straight, so it is straight line motion. Assuming the straight point of the ball O to be the origin, say assuming this as a reference point or origin, starting point, okay, can its motion from 0 to D be depicted using a horizontal line as shown? Are the values of total distance traveled and magnitude of displacement. We don't care about direction, we only care about the numerical value of displacement. That is what we mean by magnitude. So will the distance and magnitude is same when the ball is traveling from 0 to A and then traveling from 0 to B and then traveling from 0 to C? That's what they are asking. Definitely. Say imagine a ball is traveling from here to A. So what is this distance, guys? This distance is 40 centimeters. Okay, so here 0 to A, the distance is 40 centimeter, and the displacement is also distance and displacement remains same only, isn't it? Right? Say final position 40, initial 0, 40 minus 0, 40. So the distance is also 40. So now the ball is traveling. Let me change the color of the pen. Yes. Okay. So now the ball has traveled from A to B. So here is B. Okay. From 40 you should add 10 centimeters. So what is the distance for B? It is 40 plus 10. It is going to be 50 centimeters. So this much is the distance. So 50 centimeter is the distance between point 0 and point B. So point till point A it is 40. Again from here to here 10 centimeter distance. So definitely 40 plus 10. Total distance from 0 to B is 50 centimeter, isn't it? So definitely 0 to A, it's going to be 50 centimeter, and both displacement and distance is going to be same. Okay, so now 0 to C, guys. Okay, let me take another color here. Okay, so 0 to, now 0 to C. Okay, so till here it is 50, 50 plus 20. So what is the distance from 0 to C? Okay, 0 to B is 50. Now B to C it is 20 centimeter. So 50 plus 20, it is going to be 70 centimeter. Okay, so the 0 to C, it is going to be 70 centimeter, and here also distance and displacement is remaining same. Okay, now finally 0 to D. Okay, so finally we have 0 to D here, 0 to D. Okay, so for 70 you should add how much? So there is a distance between C to D, 30 centimeter. Okay, so that means 100 centimeter difference between 0 to D. So 0 to D, 100 centimeter difference, and this is also going to be same for both distance and displacement. Okay, so understanding question, carefully observing diagram is very, very important in physics. Okay, so I think these are the questions that are enough to understand distance and displacement, right? So yes guys, so that's all about distance and displacement. Now let us talk about speed and average speed. So this is very important to understand, guys. So there are two types of speeds actually. We can represent speed in two ways. One is a normal speed. Actually this normal speed, just the word speed, when you say, it actually means instantaneous speed. So very important to understand this word also. Instantaneous speed, guys. Okay, so because the word looks too big, right? So that's why we neglect that and we just call it as speed. Okay, so this is very important. Whenever a person like a science person or a science student or a science teacher, whenever they say speed, just the word speed, when they say, it actually means it's instantaneous speed. Okay, so what is this instantaneous speed? You know, it is the speed at a particular instant of time. Okay, so it is the speed, right? It is the speed at a particular instant of time. Okay, so the best example is the speedometer. Suppose, how does the speedometer inside the vehicles look like? What does it tell you? This is a speedometer, right? So at a particular time, okay, so at a particular time here, okay, so for example, say at t is equal to some t seconds. Okay, so the red color arrow is showing at 50 km per hour. Okay, that means at t is equal to t seconds, exactly you are at a speed of 50 km per second. That means you are traveling 50 kilometers in 1 second. Okay, so you are covering this much distance in this much time. That is what we refer to instantaneous speed. So at a particular time, see, when t is equal to 4 seconds, look at the speedometer, it is 0 kilometer per hour. But when t is equal to 6 seconds, look at what is the value. It is almost like 49 kilometer per hour it is showing. Say at a specific instant of time. Okay, so we have discussed the difference between instant time and time interval, right? So at exactly 4 seconds, what is the speedometer reading? At exactly 6 seconds, what is the speedometer reading? At that second, you are covering this much distance in 1 second, okay, in this much time. That is called as instantaneous speed, guys. So how do I define a speed? So the symbol for speed we can take as SP, guys. So unfortunately there is no good symbol for speed. Some books would refer V, U and different aspects, but let me consider speed as SP. So many people say speed is S, but S is a symbol which is given for displacement. Okay, so this is a symbol for displacement. You cannot use it for speed. Okay, so even in the formula, the moment you see any S, it means it's a displacement. So let me call speed as SP. So SP, that is speed, is defined as distance traveled. Okay, so distance traveled divided by time. Okay, so instantaneous speed, how do you calculate the instantaneous speed? Exactly at 6th second, what is the distance covered per second? How do you calculate all of this? So this requires differential calculus and etc. that we will see later. Now it is not necessary. Okay, so instantaneous speed means distance traveled at a specific time. Okay, right? But now, say for example, there is a person, he has traveled 30 meters in 20 seconds. Okay, so I'm not talking about 20th second he covered 30 meters. No, that's not possible. Okay, that is actually instantaneous speed. Okay, so I'm talking about from 0 to 20 seconds. Okay, so initial speed is t is equal to 0 seconds. Final speed is t is equal to 20 seconds. So in this amount of time, this person has traveled this much distance. Okay, so how do I talk about speed here? Speed is distance traveled. So here the speed is total distance traveled. Okay, so total distance traveled divided by time interval. Divided by time interval. Time interval means in this much time gap, from 0 to 20 second time gap, this person has traveled total of this much distance. That is what the meaning. Okay, so total distance traveled divided by time interval is nothing but time gap, in some time gap, which can be called as total time. Okay, so the moment you say total time, it means the time interval only. So this is what we call average speed, guys. Okay, so what we care is the average speed. Okay, so you can only easily calculate the average speed. You cannot that easily calculate instantaneous speed, and that is not so much necessary at this point of time. Okay, but what you need to know is instantaneous speed means just the speed, just the word speed, which is the distance that a object is covering at a particular instant of time. Okay, so whereas the average speed is total distance covered by a object in some time interval, in some time gap. Okay, that we call it as a total time. So we always care about the average speed, not the instantaneous speed here. Okay, so but you should know the difference between instantaneous speed and average speed. Okay, and now the speed does not has any direction. So when you just talk about the speed, we don't care about direction. Okay, and what is the unit of speed that you have here? So very important, units of speed is meter per second, guys. Okay, meter per second, or you can represent it as kilometer per hour. Okay, so anything, centimeter per minute, right? So centimeter per minute is fine, kilometer per hour, meter per second, we represent in different units. Okay, sometimes for the problems you need to convert from one unit to another unit also, that is also very important. Okay, say suppose, okay, I have 3 kilometer per hour. So convert this speed into meter per second. So 3 kilometer per hour is how many meter per second, they will ask you. So it's very simple, 3 kilometer divided by 1 hour, isn't it? So kilo means what? 1000. Okay, so 3 into 1000 meter divided by 1 hour is how many seconds, guys? 1 hour is 60 minutes and 1 minute is 60 seconds. So 60 into 60, if you do this 0 cancel, this 0 cancel, so it is 30 divided by 6 is 36 you have to do. Okay, so conversion is also very, very important. And also sometimes what they will give you is distance traveled, they will give you. So the distance traveled is 40 meter. Okay, so time taken to travel 40 meters is say 60 seconds. Okay, calculate the speed, calculate the average speed. Okay, so this word is very important, calculate what? Average speed. So how do you calculate? Just 40 divided by 60, 40 meter, total distance traveled divided by total time taken, that is 60. Okay, so this is how you can calculate. Suppose speed is given. Okay, sometimes what they'll give you is, suppose an object which is traveling with 6 meter per second speed for about 30 seconds. Okay, so calculate distance, they will ask you, calculate distance. So anything they can ask you. So speed is given, what is this? Speed is given, what is this? Time is given. So they are asking you to calculate distance. So what is the formula you have? Speed is equal to distance divided by time. So speed is given, what is the speed? 6 meter per second. Okay, so distance they are asking, distance is the question mark. So in the denominator, time 30. So what you have to do? 6 into 30 will give you the distance. Okay, so if it is an average speed, okay, if it is a constant speed, then you can use this formula, speed into time can give you the distance. Okay, so this is all about the speed, average speed. Okay, so what we commonly use is the average speed, not the instantaneous speed. Okay, so average speed is distance, total distance traveled divided by total time. So here speed they'll give, time they'll give you, they'll ask you to calculate distance, or distance and speed they will give, they might ask you to calculate time, anything. Okay, so all the three are variables. 2 variables they'll give, third one they'll ask you to calculate. Just interchange the formula and calculate it. Okay, so that is all about instantaneous speed and the average speed. Guys, now let us talk about velocity in the most beautiful way. Okay, see, suppose, okay, so I'm taking a horizontal path. Okay, so when t is equal to 0 seconds, okay, so a person was here, okay, a person was here at 20 meter. Okay, so at exactly 20 meters distance, okay, at exactly 20 meters distance from origin or from reference, okay, a person is here at t is equal to 0 seconds, guys. Okay, so now this person has moved to this point. Okay, so he has traveled around 40 meters. So the point here is 40 meters. So this point is 40 meters away from the origin, and here the time was exactly 3 seconds. Okay, so when t is equal to 0, this person was at 20 meters away from origin, and he traveled some distance about 20 meters more, and now he is there at 40 meter distance from origin, and the time exactly when he was here, the time was showing 3 seconds. Okay, fine. So now guys, what is the displacement here? So yes, there is some distance traveled, that too in which direction? He traveled in this direction. Okay, so definitely what is this? This is the final position. Okay, position I am talking about, x is the symbol for position, and this is the initial position. Okay, so final position of an object is 40 meter, initial position of the object is 20 meter. So what is the change in the position? This itself we will call displacement, no? So what do you mean by displacement? Change in the position. He was here initially, now he is at this point. So what is the change in the position? That is delta x is equal to xf minus xi. What is xf? 40 minus 20, that is 20 meters. Okay, so what is displacement? So displacement is represented with the symbol s. Okay, so the s is 20 meter. And now what is the time change here? In how much time? So what is the time change? In how much time he could travel this 20 meter distance? It is 3 seconds minus 0 seconds, that is 3 seconds. So the time taken, okay, for this displacement to happen was 3 seconds. Okay, so now what is velocity is, it's very simple, right? Actually this itself we will call it as a motion, right? So the change in position as time changes, what is this? This itself is called as a motion. Motion itself is nothing but velocity. So what is velocity? Change in displacement with respect to time, guys. Okay, so very important. So change in displacement, again displacement means what? Change in position, right? So but in a certain direction, when you add direction it is a displacement. Okay, so change in displacement with time, okay, with time is called as velocity. So you can write it as a formula here. So V can be a symbol for velocity. Velocity is equal to displacement divided by time, total time, okay, divided by total time taken. Okay, so that means in the time interval, in this much time gap, okay, get here, in this much time gap, this much was the displacement observed. That is what we call it as average velocity, guys. So average velocity is indicated with the line above V. Okay, so what kind of velocity it is? It is average velocity. Okay, so whenever we talk about velocity in a chapter, okay, it is actually a average velocity most of the time we discuss, and this average velocity itself is called as a motion or uniform motion. Okay, so you need to understand the word uniform motion here. Motion itself means velocity. Then why do we talk about speed? Because we are from small we are used to the word speed, that's why we discussed. Otherwise speed has no importance. See, what do you do with the speed when you don't care about a direction? It's very important, no? See, a car is traveling with a great speed. Okay, it is traveling this much distance in this much time, but which direction is it traveling matters a lot. Okay, so the moment you include direction, yes, it's not the distance that we should care, it is the displacement that we should care, isn't it? Right? So velocity is more important than speed actually, because here direction is also included. Okay, right? So this uniform, the word uniform means constant here. So every now and then we use this word uniform, means uniform, right? So what do you mean by uniform? It means constant. So constant motion, uniform motion, constant velocity or average velocity, everything meaning wise it is same. Okay, everybody type this in the comment section. Meaning wise, uniform motion, average velocity, constant velocity, all of that remains same. Okay, right? So now whenever average velocity is given, you can always calculate the displacement here. So what is displacement here? Displacement is nothing but average velocity into time, isn't it? So average velocity into time will always give you the displacement, guys. Okay, so here also same thing. When you know average velocity and displacement, you can calculate the time. Okay, when you know displacement and total time taken, you can calculate average velocity. So when you know average velocity and time, you can calculate displacement. So this formula is very, very important, this idea. Okay, so now like we had instantaneous speed, we also have instantaneous velocity, which is actually very important also, instantaneous velocity. Okay, but what is instantaneous velocity? Velocity at the instant of time. But velocity at the instant of time is very difficult to calculate, but you can do that using calculus, okay, which we will discuss later. Okay, so that is about instantaneous velocity, guys. Okay, so just when you say a word velocity, it actually means instantaneous velocity. Okay, so you have to specify what kind of velocity actually. Okay, so it is most of the time we discuss with average velocity. Okay, so average velocity, when you know two variables, the third variable can easily be calculated. Okay, but it is not the case with instantaneous velocity actually. Okay, so hope you understood, and definitely the velocity has got a direction, isn't it? So here the velocity can be negative. If the velocity is negative, okay, say suppose on a number line, say I have an object moving with 3 meter per second velocity. So velocity is 3 meter per second in positive direction. If the object is moving like this, then it is plus 3 meter per second. The velocity value is plus 3 meter per second. But the same object, if it is moving on the opposite direction, you call the value as minus 3 meter per second. So the object is moving with minus 3 meter per second, we say. So what is the importance of plus and minus here? Plus means it is moving in a forward direction, and minus means it is moving in the opposite direction, as long as the motion is straight here. Okay, so we are only talking about motion in straight line. It is about the uniform motion. Okay, so uniform motion means it's a uniform velocity, where velocity is constant at every time interval. Velocity is constant at every time interval. That's what we mean by uniform velocity. Okay, uniform motion. Now let us do one interesting problem, guys. So there is an object which is moving with 3 meter per second velocity. So the velocity is 3 meter per second, and it has moved up to for about 2 seconds. Okay, and it has come to this position, and now from this position to this position, again the velocity is like it is moving with 4 meter per second for about 6 seconds. Okay, right? So now from here it came back to again this position. Okay, so it has not gone down, it came back to this position where the velocity here is for about 5 meter per second, and it took 3 seconds time. Okay, so now it is the final position. So now it is the final position, guys. Okay, so what you have to calculate is average speed okay, as well as average velocity. You need to calculate average speed and average velocity. So here actually there is a difference between speed and velocity, right? Imagine you don't care about the direction. Okay, so we don't care about the direction here. So what I meant you to calculate is the magnitude of average velocity. I just want the numerical number. I don't care about the direction. Okay, you can't add all these speeds and then divided by the total time. No. Okay, look at here. The speed is changed from here to here. It has changed from here to here. But from this point to this point it is constant. Okay, so as long as it is constant from this point to this point. Actually, these kind of problems are called piece by piece problems. Okay, piece by piece, first you have to find out what is required. Okay, say what is average speed, guys? It is the total distance traveled by total time taken. Okay, so first you need to find out the distance. Find out the distance from this point to this point here. Okay, how do you find out the distance? See, the speed is given, time is given. Okay, so the average speed or velocity is given, time is given. So how do you find out the distance? So distance is equal to your velocity or your speed into time, isn't it? So what you will do? 3 into 2, that is 3 2s are 6 meters. So this is the distance from this point to this point. Again, from this point to this point, 4 6 are, right? So that is 24 meters. Okay, now from this point to this point, 3 5s are 15 meters. Okay, so now you add, right? So now you add 6 meters plus 24 meters plus 15 meters. So this is the distance traveled by this object to reach from this point to this point. Hope you understood, right? So the distance taken by this object to move from this point to this point is this much distance. So how did you calculate the distance? The speed is given, or I can call it as speed or velocity, same when I don't care about the direction, right? So calculate the distance, what we have done, just we multiplied the speed value with the time value, and then we got the distances. Okay, piece by piece we have done. Okay, yes. So now divided by the total time. Total time is 2 seconds plus 6 seconds, 2 seconds from here to here, from here to here 6 seconds, from here to here 3 seconds. That's it. So you add all this and you add all this and you will calculate. But now how do you calculate the average velocity? So average velocity is nothing but the displacement by time, right? So when you forget about the direction, so I'm finding out the magnitude of average velocity here. Okay, so magnitude of average velocity is displacement time. What is displacement? How much is the displacement here, guys? So observe here. So you started at this point and you know you are at this point. So what is the displacement? Imagine if it is a straight line motion, you are coming back on a same line, the displacement is only 6 meters, right? So 6 meters is the displacement, but what is the total time for this displacement to happen? Total time is this only, 2 plus 6 plus 3. Okay, so that is how you will calculate the average velocity. Okay, so hope you are clear with the difference between calculation of average speed and average velocity, isn't it, right? So it is a piece by piece problem. So piece by piece, when you look at this velocity or the speed remains constant, guys. So that is the reason we could able to calculate the distance or displacement using this formula. Distance is equal to speed or velocity, okay, into time. Right? So if you want to calculate displacement, it is velocity into time. If you want to calculate distance, it is speed into time. Okay, right? So this is how you must get an idea to solve the problems on average speed and average velocity. And now coming to acceleration, guys. Acceleration, see, velocity is change in displacement divided by total time. Okay, so from one point to another point, okay, what is the change took place in position in a particular span of time. So that is what we mean by velocity, as well as motion or velocity here means same, technically speaking. Okay, I'm talking about uniform motion and average velocity, all of this is same. Now if you want to speed up the vehicle, right, so acceleration is like speeding up. Okay, so for example, understand this particular concept, guys. Say for example, an object is there which has got a initial velocity 3 meter per second. It is traveling with the velocity. So this is my initial velocity. Okay, so initial velocity, so that is starting velocity. See, initial velocity every time it need not to be 0. Okay, initial point every time need not to be 0. It is my wish. Okay, at any point can be a initial wish. Okay, or initial velocity. So what do you mean by this value, guys? So this particular object has traveled, okay, 3 meters in 1 second. That is what the meaning of the velocity. No, it has traveled how much? 3 meters. Okay, it displaced 3 meters of length in this direction in 1 second. That is what the meaning of this velocity, right? So this particular number. So now imagine I am adding more speed here. Okay, so I am adding much more velocity to this. I am adding 2 meter per second in every second. Okay, so in 1 second, I mean in 1 second of span, how much is the velocity I added to the initial velocity, right? 2 meter per second of velocity I added per second. In every second I am adding 2 meters per second velocity. So what would be the final velocity? What would be the final velocity here? So final velocity is 3 meter. This fellow would have had 3 meter per second, plus you added extra 2 meters, 2 meter per second. Okay, so total this fellow's velocity is 5 meter per second, guys. Okay, so now again I am adding 2 meter per second in the next second also. So even in the next second of span, okay, I am adding 2 meters per second to this, so that at the end this object would be having how much? 5 meter per second, plus I have added 2 meter per second, so that is 7 meter per second velocity it will have, isn't it, right? So now this becomes a final velocity. Now this becomes a final velocity. Guys. So acceleration is that extra speed that you are adding to original speed or velocity to increase, to go faster. Okay, so to go faster you are adding an extra velocity to the initial velocity. Okay, so that is what we mean by acceleration. It makes the object to move much more faster in the course of a journey, right? So that is what acceleration here. Okay, so usually how do we define acceleration? So what is acceleration here, right? What is acceleration? Look at here. What is the final velocity here? Right, final velocity is 5 meter per second, initial velocity is 3 meter per second. So when do you get this value? When do you get 2 meter per second value? So when you do final velocity, okay, let me call final velocity of an object as Vf, initial velocity of an object as Vi. So when you do final velocity minus initial velocity, okay, and again the time difference, this is the time interval that took for the velocity to change. Okay, so time taken, this is what we call acceleration. So acceleration is nothing but change in velocity, okay, with time. with time, change in velocity with time. So it is like you are increasing the speed of an object to move by adding an extra little bit of velocity to the initial one, to the existing one. Okay, so technically speaking, how do you define acceleration? It is the change in velocity in some span of time. Okay, in some span of time, that is time taken. Okay, so change in displacement by time taken is velocity, but change in velocity by time taken is called acceleration. Again, this is a average acceleration. So what kind of acceleration I am talking about? Average acceleration, guys, because I'm finding the change within a particular time interval. I'm not finding the speed of an object or acceleration of an object at an instant of time. That is instantaneous acceleration. So here we are interested in finding the acceleration in the span of some time, that is in some time interval. So it's a average acceleration that we are talking about. Okay, so definitely it will have units. What? So units of acceleration is, it's a velocity change by time, no? So velocity unit is meter per second, right? So meter per second divided by second, you will have meter second inverse square. Okay, so ms minus 2. Okay, meter per second square. You can also say it as meter per second square. Okay, or you can just say meter second minus 2. Okay, so this is the unit of velocity, sorry, that is the unit of acceleration, and this is the definition and meaning of acceleration, guys. So it is like you are adding some extra velocity to the initial one, so finally it's moving with more velocity in a particular direction. When velocity has got a direction, acceleration also will have a direction. So acceleration is also a vector quantity here. Okay, so that's all about average speed, average velocity and average acceleration. So you should clearly know the difference between instantaneous speed, instantaneous velocity, instantaneous acceleration, and average speed, average velocity and average acceleration. So that's all about this video. See you in the next video with the next concept. Okay, so hope you enjoyed the video. If you have enjoyed and understood the concepts, type S in the chat section, guys.